Hi everyone, today we are going to do section 1.6, phase shift and sinusoidal curve fitting. First, we are going to start with general equation of sinusoidal curve. It looks like a normal equation for a sine with a little arbitrary parameters. Y equals A sine of omega x minus phi plus b. What is what over here? We know that A is amplitude. Amplitude is how far away sine goes from the middle line. So if you take a sine, draw a middle line in the middle of the sine, amplitude is how far it goes up and down. What else do we know? We know omega. Omega is a frequency. Frequency shows us how often sine is doing oscillations. Usually we use omega to find period. Period is 2 pi over omega, right? And bigger omega means smaller period, and smaller omega means bigger period. Last thing we learned already was B, vertical shift. What vertical shift is doing? It's taking the whole sinusoidal curve, looking like a wave, and shifting it either up or down, depending on whether it's positive or negative. Positive vertical shift means that it's going to be moved up. Negative vertical shift is going to be moved down. Now, the only one letter we don't know yet in this formula is letter phi. Letter phi is going to define for us phase shift. It's not phase shift itself, but it's going to define for us phase shift. You see that this phi is subtracted from omega x. So it's not subtracted from the whole function. Means that it's going to affect somehow position of the function on x-axis. Actually, it's going to shift it along x-axis, either to the left or to the right. Let's consider a simple function without vertical shift. It's going to be a little bit easier to kind of deal with it. So let's consider y equals a sine of omega x minus phi. So I dropped vertical shift. Whenever we need it, we're going to add it again. What I'm going to do here, I'm going to take omega, like I was always doing it. Remember when I was calculating the period, fundamental period, outside of the parentheses for the first term and for the second term. For the first term, because it's a product, it's easy. You just take it outside. For the second term, I'm going to divide it by omega and multiplied by omega. The multiplied omega is going to go outside of parentheses. Divided is going to stay phi over omega. You see that actually this phi is going to move or give horizontal shift in x direction to the number phi divided over omega. And that's going to affect our graph and shift it to the right. Remember, if we subtract something from x, we are shifting our graph to the right. If we have no phi, actually, the graph is just going to be a normal graph, right? And the graph is going to have value y equals 0 at x equals 0, right? Imagine that we have no phi here. You plug in x equals 0, you get sine of 0, which is equal to 0, so y is going to be equal to 0. Now, we do have phi. How do we get y equals 0 if we do have phi? Well, now we'll need to make the whole thing equals to 0, right? To make argument of sine 0 and produce y equals phi. So y equals 0 is going to happen when? When omega x minus phi over omega equals 0. Omega here is a number, so we can divide by it and it's never 0. So we're going to get something like omega minus phi over omega equals 0, or we are going to have x equals omega over phi over omega. This is actually called phase shift. This is phase shift. Phase shift. Okay? And the very simple way to find actually phase shift is to find out x for which argument of sine is going to be equal to 0, because this x is going to produce actually a special point for us, 0, 0. Let me show it on the graph. If you do the graph of normal sine, how it's going to look? Well, I'm going to graph only positive part. It's going to look like this, right? something like this, going up and down, right? 2 pi over here. The graph goes from 0, 0 point and goes up to the point 1 pi over 2 and then goes down and so on, right? But now, to make argument equals to 0, we're supposed to set up x to phi over omega. So actually what is going to happen to the graph is going to be shifted in comparison its original position to the magnitude phi over omega. So it's going to start over here. Basically that point, which was here, is going to move to the magnitude phi over omega. And of course, because sine does not start actually here, it kind of just, we're just drawing it from here. There is going to be a part which goes like behind, and the sine is not going to start from this point, but actually the point where 0 happens is going to be moved. Okay, we are going to call this phi over omega, phase shift. And again, you can either memorize formulas that number over omega after minus is going to give you phase shift, or just find out when argument is equal to 0. It's going to give you also phase shift. It's just going to give you x from which sine is going to start. Instead of 0, 0 point, it's going to start from that point. Okay? Phase shifts can be positive or negative, so we can equally move the graph to the right or to the left. Negative phase shift is going to happen when we do have omega x plus phi. This way, you are going to have x equals minus phi over omega, and that's going to shift the graph to the left. We call it negative phase shift, but actually it's just a graph shifted to the left. Okay, let's consider example. Example, y equals sine of 2x minus pi over 2. I'm kind of using amplitude equals to 1, and I'm using vertical shift equals to 0. So I'm making it very, very just concentrated about this horizontal shift. Well, I'm going to start with finding phase shift. What I'm going to do, I'm going to set 2x minus pi over 2 to 0, and calculate what is going to be x. X is pi over 2. I'm moving pi over 2 to the right side and divide by 2, which is going to give me pi over 4. That's going to be the beginning of my sine. Now, instead of starting my sine from 0, 0 point, as I usually do, like this, I'm going to start my sine from point pi over 4. The only one little thing I'll need to know, how big is the period of the sine? How far is pi over 4? Is it here, 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 or here? So to calculate the period, I'm going to take 2 pi and divide over omega, which is equal to 2. 2 pi over 2 is going to give me pi. So actually the whole period of sine is pi, and this is going to be pi over 2 then, right, half of it, and this is going to be pi over 4. Pi over 4. So I'm going to move my sine to this point, that my sine is going to look like this. This is called phase shift. Of course, over here there is continuation of the same sign. Okay, so very good idea is to set it to 0. But if you like to memorize formulas, it's also not going to be bad to memorize formulas. Okay, so let's consider example from the book. Give us example, and that's example 2, I think. I'm going to label it example from the book. Example from the book is y equals 2 cosine of 4x plus 3 pi. Well, slightly different function, but all I said about horizontal shift is going to be same for cosine 2. So I'm going to start with finding the period. That's going to be easiest thing. So first, period. Period of this function is going to be what? 2 pi divided over 4. Omega is 4, so it's pi, if I cancel it, over 2. Amplitude, how big is going to be this cosine is 2. The coefficient, if it's negative, we are going to take absolute value. And the phase shift, I'm going to set up 4x plus 3 pi equals to 0 to find out where is going to be my 0, 0x. Which is going to give me what? X equals negative 3 pi, I'm moving 3 pi to the right side, divided over 4. So actually this phase shift is going to be to the left. Negative phase shift is to the left. To the left. Okay? So what I'm going to do, guys, I'm going to graph original cosine first without phase shift and then graph the cosine with phase shift. It's going to be a little bit easier. If you do see how to graph it with phase shift right away, you can do it, of course. It's just like, because I'm explaining at a lecture, I will try to make it as understandable as possible. But again, if you see how it's going to look right away, please do it. So normal cosine starts somewhere here. Remember U shape. I'm going to make it like a big one. I'm always drawing little tiny cosines and sines. This one is going to be a big one. Okay, so I'm gonna start here, then go through this point, then go up, back, and then this direction and this direction, a little bit more than one period. Now, I'll need to label one period, right? One period here is pi over 2. So actually, this is number pi over 2, and this number is pi over 4. I'm not going to label all the points, but you understand. What is going to be the top? Amplitude is 2, so top is 2, and the bottom is negative 2. So actually, I already graphed everything besides the phase shift. Now I have to take the whole cosine and shift it negative 3 pi over 4. Negative 3 pi over 4. Well, it looks like 1 pi over 4 is going to be 4 squares. I'll need 3 pi over 4. I'll need 3 of them. Well, I think I'm going to squeeze it a little bit. At 3 pi over 4, 4 squares is going to take me very far away this way, right? So what I'm going to do, guys, I'm going to allow, like, for 1 pi over 4, I'm going to draw my coordinate plane over here, right? So my 1 pi over 4 is going to be like here. My 2 pi over 4, which is pi over 2, is going to be here. And my 3 pi over 4 is going to be here. Why do I write down pi over 2? 2 pi over 4 is pi over 2, actually. And that's where my graph's supposed to start. Right? How big is going to be one period? Remember, one period is pi over 2. Well, from where to where? Pi over 2 is going to be 3 pi over 4 and pi over 4. Pi over 2 is actually going to be the distance between these 2 points. So that's what I'm going to label. My first point, my last point on the period, and I'm going to make a nice graph. And that's going to be one period of cosine. Of course, everyone wants more than one period. So this actually point is supposed to be coming a little bit to the left. But I'll try to do my best. So that's what is going to be the graph. 2, negative 2. And I graphed it with horizontal shift. So I shifted it 3 pi over 4. 3 pi over 4. Remember, it's important to also know the period, because it's not like always period is equal to 2 pi. In this case, for example, our period was just pi over 2, 4 times shorter. Okay? So, next thing, well, we know how to deal with phase shift. Phase shift is going to be absolutely same for all trigonometric curves. So it's the same for sine, same for cosine, same for secant, same for cosecant, same for tangent, and same for cotangent. The idea is to find out how a special point, like 0, 0 point, is going to move. Okay? And there's nothing like special or mystical about this. Okay. Now I'm going to move to curve fitting. Curve fitting. What is curve fitting? Curve fitting happens when somebody gives you the picture which looks like a sine or cosine, but they don't give you the formula. And you will need to actually find what kind of formula this picture is going to produce. When do you get pictures instead of formulas? Well, not in math book, of course, but for example, you use oscilloscope. Oscilloscope is a device to measure electric voltage, electric current, something like this, to graph it actually. On the screen, you see the picture looking like, let me graph it. I'm going to graph the picture and then explain you what is curve fitting. That's 1, 2, 3, 4. And over here I have 2, over here 4. My scale is not same on y-axis and x-axis. Well, sometimes it's going to be same, sometimes not. So it's 1 square per 2 units on x-axis and 1 square per 1 unit on the y-axis. Well, it's just kind of convenient thing to me. And I'm going to graph the curve. Let me see, the point is here and then over here. Usually you are not going to have infinite sine or cosine, because all devices, you know, they can go as far as the screen goes. You're probably going to have 1 period, 2 periods, something like this. Well, you obviously see that there is 1 period of some function, right? And kind of you see the numbers. That's normal picture on a oscilloscope. Now, can you find out what was kind of the function which was producing it? We are searching for a function of this shape, a sine of omega x minus phi plus b. So actually what we'll need to find, a, omega, phi, and b. Okay, they are unknown. We're already assuming that it's sine. Actually, we can search for cosine too, but I'm going to teach you how to search for sine. We are going to fit sinusoidal curve. But again, cosine is not like worse at sine. It's just like one of possibilities. We are going to start with amplitude. How do we find amplitude? To find amplitude, we are going to mark the top point and the bottom point and see what is the distance between these points. On my picture, you see it's 3 units, right? But if the picture is not super clear, how do we find amplitude? Amplitude is going to be calculated as upper point, upper y, minus lower y divided over 2. So basically you take this number 4, subtract 1, you get 3 units, divide over 2. Amplitude is half, right? Because amplitude is how far it goes from the middle. Middle starts over here. Okay, in our case, we have 4 minus 1 divided over 2, which is going to give you 3 over 2, which is 1.5. So my amplitude is 1.5. Good, I already know one number. What is going to be my vertical shift? My vertical shift is how far away my middle line is from x-axis, like this. In the picture, you already see that it's 2.5, right? Now, how do we find it mathematically? To find it mathematically, we'll need to find the middle of this interval. Remember how we find the middle? We take the upper y plus lower y and divide over 2, the middle of interval. So for example, 4 plus 1 is going to give us 5 over 2 is going to give us 5 over 2 or 2.5. Oh, already know 2 numbers, right? How do we find omega? Remember that period equals 2 pi over omega, from where we know that omega, actually, phi equals 2 pi over period. Now, how do we find the period? Well, remember that period is like how big is the picture before it starts repeating itself. For example, from this point to this point, I'm going to estimate the period. That's going to be my period. Because after this point, it's going to repeat itself, right? It looks like it's 8 units. So I'm going to take 2 pi over 8 and half pi over 4. And I found omega already. Let me write it down. Y equals a sine of pi over 4x minus phi plus, well, instead of a, I should write down 1.5. Sorry, that's not a, 1.5 plus 2.5. I just need to find phi. What I need to add. How do we find phi? Well, you can do it graphically or you can do some reasoning. I'm going to do it graphically here. Remember, if we are doing the sine, imagine that you want to kind of consider this as a picture of classical sine. Your sine is going to start at this point, right? Normally sine starts like in the middle, goes up and then down and then goes back up. That's your sine actually. Right? My sine looks like somebody moved it 2 units actually to the right. So my phase shift, which is x, which is equal phi over omega, is equal to 2 units. Somebody moved it 2 units to the right. Okay, so what is then phi? We just substitute everything. So 2 instead of x, phi is unknown, and omega is pi over 4. Multiply by pi over 4, we are going to get pi over 2 equals phi. So that's my phase shift. My final picture is 1.5 sine pi over 4x minus pi over 2 plus 2.5. Well, what if you don't want to solve this equation? You know that the picture is going to start at point 2, x is equal to 2, it's shifted 2 units, right? So you put 2 here and make this one equals to 0. It's going to give you phi right away. If you put 2 here, it's going to be 2 pi over 4, which is pi over 2. Also, that's going to give you a very same number, pi over 2. Okay? Well, Now I think you can try to graph something. I'm going to put a couple of problems for self-graphing and we'll take a pause. Self. Number 1, graph y equals 3 sine x over 2 plus pi over 4 plus 3. Number 2, find a sine function y equals a sine of omega x minus phi plus b that fits the graph. Well, there's going to be the graph which I want you to fit. Let me see, 3, 1, 2, 3, 2 here. Okay, so there's going to be 1, there's going to be 2, there's going to be 1 here and 2 here. Let me see. So what I want to start over here at 2, go here, and return back, and then go this direction, then go this direction. You will need to see 1 period here. Okay, so the number here is -1, this is x, this is y. So I'll let you like work on it for like maybe 5 minutes. You can do whatever you like, and I'm going to just wait a little bit and show solutions of these 2 problems. Okay. Okay, solutions. The solutions. For problem 1, what is going to be the amplitude? Amplitude is 3, right? Vertical shift is 3, 2. Interesting, right? Omega is 1/2, so the period is 2 pi over 1/2, which is going to give us 4 pi. And the phase shift, I'm just going to set up x over 2 plus pi over 4 equals 0, which is going to give me phase shift minus pi over 4 multiplied by 2. I move pi over 4 this direction, minus, right? And then multiply by 2 both sides, which is going to produce what? Negative pi over 2. Well, I'm going to write down here, negative pi over 2. Well, now I know everything. And what I'm going to do, guys, I'm going to do several steps. I think it's going to be a little bit easier for you to understand. So I'm going to start with normal sine with amplitude 3 and the period of 4 pi. No, I'm not super creative. I'm just drawing my standard sine. And that's going to be counted as 3. That's going to be counted as -3. And the 1 period is going to be counted as 4 pi. So this is somewhere 2 pi. Okay? Now, what I'm going to do? Well, you can do vertical shift first and then horizontal, or horizontal first and then vertical. I'll do, I think, maybe horizontal first. Actually, I don't really know. Whichever like. Okay, if we do horizontal shift is minus pi over 2, so we're moving it to the left. We do have 2 pi here, so that's going to be pi, and pi over 2, it's a half of my square. So my shifted one is going to be shifted to here. This is negative pi over 2, the number. And that's going to be, kind of everything is going to be shifted half of a square from its position. Like this. I'm trying to do my best to shift everything half of a square. Okay, so I did my horizontal shift. Now vertical shift is 3 units up. So 3 units up means that I want to take this middle line or the whole graph and move it 3 units up. 3 units up is going to move this point, for example, which is -3, to the point 0. Well, I don't think that I'll fit anything here. I'm going to just graph one more thing. So this point is half of a square. It's gonna move over here. What else? The point which was over here is going to be here or in the middle. The bottom point was over here, is going to move here and a little bit like half. Okay, something like this. Okay, so this is minus pi over 4, or pi over 2, sorry, pi over 2. This is going to be 6, this is going to be 0. We shifted everything 3 units up. What else? Well, my other points. If this is pi over 2, my whole period is supposed to be 4 pi, right? But that's going to be a little bit less. So I'm going to see where my whole period is going to happen, somewhere here, right? And the point is going to be pi over 2 less. So that's going to be 7 pi over 2. 7 pi over 2. Well, my graph doesn't look very pretty. We can do it better. But that's basically it. For the first problem, we do 2 transformations and we have our graph. For the second problem, what do we see on the graph? I'm just going to use the graph to label all the stuff on the graph. First, the amplitude. This distance over 2, right? From 2 to 1, like 3 squares. So we have, sorry, for problem 2, amplitude is going to be 2 minus negative 1 over 2, which is going to give me 3 over 2, again 1.5. What else? Vertical shift, B. The same numbers, but added. 2 plus negative 1 over 2. 2 minus 1 is 1, so 1/2 vertical shift. The period. Let's look at the period. Looks like it starts here and ends here, so 1 period is 2 units. So I'm going to calculate omega 2 pi divided over 2, which is a period. I'm going to label period as 2 units, which is just pi. Okay, my omega is pi. And the last thing, the phase shift. Well, what I'm going to do, I'm going to write down what I have in parentheses and sine. I have sine of pi x minus phi, right? Now I'll need to look at my graph and think, okay, if it is sine, it's going to start over here, right? Normally sine starts like in the middle line. And that's going to start at negative 1, actually. So we have negative 1 as a start point. I'm going to put negative 1 instead of x. Then minus phi, sorry, plus equals 0. What I see is that my phi, if I move it, it's going to become positive here, is equal minus pi. Maybe I did something wrong. Let me double check it. Yeah, I did something wrong. This is not negative 1, actually. If I look at my graph, my 1 is here, so my negative 1 is here. This is 1 is not. It's 0.5, actually. So I'll need to fix it a little bit. 0.5 means that it's not negative 1, but negative 0.5. Negative 0.5. And negative 0.5 is going to give me phi, which is negative phi over 2, I guess, right? Well, that's fine. Let me double check my numbers. Everything looks fine. I just did not see that the point was not 1, actually. It was 1 is 2 squares, and I have like 2 squares over here. So minus 1 sits over here. This is minus 1. And this is 0 minus 0.5. So it shifted 0.5. Okay. Well, I think I'm just going to write down equation. Y equals, my amplitude is 1.5, then sine, then omega, which is pi x, right? minus pi over 2 is going to give me plus pi over 2, and plus b, which is, what is my b? 1/2. And that's my final answer. Well, guys, interestingly, that in the book, when you do the homework, sometimes you are going to have the horizontal shift different by one period from what you have. You understand that, for example, if you look at this curve, right, you can consider that sine starts here, or actually it starts here. And it's basically going to be like two different horizontal shifts. This one is going to be positive, and this one is going to be negative. It's not like one is wrong and one is right, but you're supposed to understand that your answer can be different from the answer from the book. So for example, if I consider that sine starts over here, it's 1.5 actually, and my shift is going to be minus 3 pi over 2. Well, again, both answers are correct. Well, I think that's all for this section 6. And I'm going to take pictures of my notes and put it online. Okay, thank you very much.